In this example, we have an application, and we're going to use system of equations to solve it. Let's read it. The admission fee at an amusement park is $1.50 for children and $4 for adults. On a certain day, 302 people entered the park, and the admission fees collected total to $878. How many children and how many adults were admitted? So the first thing that you want to do whenever you're using systems of equations is you want to identify what you're going to say is going to be your x and your y. You can use any other variable, but I always like to use x and y. So we're talking about two things. We're talking about the cost per children and the cost per adults. I'm going to say that x is going to be the children and that y is going to be the adults. All right? If you think about it, you have two things here going on. You're talking about people going into the park. So the number of people, that gives you a total amount of people, right? And then it gives you a total amount of money coming in based on the number of people. That tells me that I'm going to have two types of equations. One equation is going to be with the people information, and one equation is going to be with the money amount information. So two types of equations. This just helps me organize my work. Okay. One is going to be a people, and the other one's going to be money. All right, well, let's see. For the people equation, am I told how many people, how many children were in on that specific day? It doesn't say. And I'm not told how many adults were in on that specific day. I only know that the total of people that went in were 302. So I don't know the number of children, nor the number of adults, but I do know that it was a total of 302. All right. Now, I don't know specifically how much money came in for the children's, but I do know that $1.50 cost for each children to come in. So I'm going to say 150x plus 4y, and this will give me a grand total of $878. If you notice here, you have your system of equations. Two equations. Now, they're both in standard form, so my suggestion is to use elimination method to solve it. So I'm going to use, I will use, let's put there, I will use elimination method. All right, I'm going to label this as my line 1 and line 2. Okay, so let's see. So if I want to cancel the x's, which I always go for the x's, I'm going to multiply line 1 by negative 150. Because when you are doing elimination method, the goal is to eliminate one of the two variables. And in this case, I want to eliminate the x. So in order to eliminate them, when I add both equations, they have to be the same number but opposite signs. So I'm going to multiply line 1 by negative 1.50. All right, so that's going to change to negative 1.50x minus 1.50y equals, get my calculator over here, 302 times negative 1.5, negative 473. Negative, what is it? 453. I'm going to write the other one on the bottom. And now I'm going to add both equations. This one is going to cancel out. Now I'm going to be left with one equation in with just the variable y, which is what I want. I have 2.5y equals negative 453 plus 878 425. Then I'm going to divide both sides by 2.5. Gives me y equals 170. Now I need to find the x. So I'm going to go ahead and substitute the 170 in line 1. I'm going to use line 1 because line 1 is easier. So I know that y is 170. So I'm going to minus the 170. And then I'm going to subtract. Gives me 132. Now let's go back and read the question in the problem. It says how many children and how many adults were admitted. So I know that, sorry, I know that the x tells me the number of children. So this is 132 children. And 170 adults were admitted to the park on that specific day. And there you have it.